We're going to discuss today about the differences between machine learning and deep learning. So, in the last year, you have completed the course of machine learning, and let me quickly recap what is what is meant by the machine learning and what we were doing. So, in machine learning is when, according to the Tom Mitchell's definition, when the performance of a model improves with time for a task T with time means with experience. If P improves with experience for a task T, then we call that it is a learning process. So we have seen that there are three categories of learning: supervised learning, where we'll be given with a set of features X and a corresponding label Y. And we have to design a model that we want to find the representation of Y in terms of X, maybe X1, X2, X3, so on. So, in other words, supervised learning is done with labeled data. You'll be given with labels. Suppose somebody want to teach you which is dog and which is cat, and they will show you the image of dog and say that this is dog and this is cat. So they will tell you the output label, what is there. So this is known as supervised learning. And secondly, we have unsupervised learning. Unsupervised learning, where you'll be given only with the set of features, but you don't know what is the label. You may be given with all the animal pictures, but you don't know which is dog, which is cat. You don't know about whether it is dog or cat. You know that this is group one, this is group two. That means you'll be looking for the underlying patterns of the data. Patterns of the data. In other words, we'll be given with unlabeled data. And third category of machine learning algorithms falls in reinforced learning, which is dealt with a separate paradigm where the model will learn not with the data but with reward and punishment. If somebody says if playing a computer game, if you go to a particular place, you will get reward. So always you want to go to that place, and if you go to another place, you may penalize it. So that is with what we say reward and punishment paradigm. Now, uh, in supervised learning, two important categories that we have seen. One is known as classification. Classification. A discrete, what we say, a categorical value that we'll be using. Classification, something like, whether this is dog or cat. That is binary classification. And sometimes you may have multi-class classification, binary or multi-class categorical value. They're always, the output label is categorical. It is not continuous, something like yes or no. For example, a person is diagnosed with a particular disease, yes or no, that is a classification problem. Whether tomorrow it will rain or not, that is a classification problem. Tomorrow India will win cricket match or not, this is a classification problem. So in classification problem, you have discrete output, discontinuous, a particular category, yes, no, or class 1, uh, class 2. One is given image, whether it is dog or cat or donkey or monkey. This is classification where the output is discrete. And second type of problems in supervised learning is regression, where you'll be predicting a continuous value, something like what will be the temperature tomorrow. It is a continuous value. It can be 25, it can be 25.5, 25.6, 30, 31, 32. All the values are continuous. So that is a regression problem. Uh, what will be the share price of SBI tomorrow? That is a prediction, continuous problem. Based on certain values, what will be the price of a particular given house for selling? That is a regression. So I hope you understood the difference between classification and regression. Classification, discrete output; regression, continuous output or prediction of a value. And if you remember, we have talked about in supervised learning, we talked about linear regression, where you'll be assuming that y is a linear function of x, something like y is equal to mx plus c, then polynomial regression, then we also talked about decision trees, and the decision trees are modified as ensemble learning, random forest, boosting, SVM, support vector, machine, k nearest neighbors. All these are supervised learning algorithms where you'll be given with input as well as the output. But when it comes to unsupervised learning, you'll be given only with uh, x value. That means when it is given, you have to assign or you have to look for uh, the patterns in that, how that will group together. So unsupervised learning algorithms are used for a particular problem known as clustering. Clustering. So here we studied k-means clustering, data DB scan, k-medoids algorithm. So how they are clustered, though we don't know the label, but still we can group them. So for example, you may not know whether it is dog or cat, but you can put all the dog images into one class. You can call that as a class A, and all the images of cat into another class, and you call it class B. So that is clustering. Clustering. The third one we will not be focusing much here in this course. That is known as reinforcement learning. There, and when we talk about machine learning algorithms, we talked about our concept is we want to find the weights. We will be given with, suppose it is supervised learning, we will be given with x and y. We assume a model y is equal to something like bias plus a set of weights w1 x1 plus w2 x2 so on plus so on wn xn. And our goal is we want to find a set of weights so that the error, what we mean by error? Error is the actual value is y and your computed value is y cap. So the difference between y and y cap is known as error function, or we call it loss, we call it cost function, sometimes we call it objective function, and we want this to be minimum. The most generally used cost function is mean squarer, where you'll be calculating the difference between the squares. Why square? Because you may get positive difference in one case, negative difference in another case. So you may have positive negative differences. To avoid that, we'll be calculating this. So 1 by n y minus y cap whole square can be called as mean square error. And similarly, you can have, instead of squaring, if you have the only values, we can call that as mean absolute error. If it is binary classification problem, we calculate binary cross entropy. And if it is multi-class classification problem, we talk about categorical cross entropy. Then we have another called KL divergence. These are all loss functions: divergence, hinge loss, Huber loss. These are all different loss functions. So let us say this is error E. So we want to find out the weight such that the gradient dou E by dou Wi is minimum or zero. So at this point, where the gradient of E is less than zero or equal to zero, there we want to find out the weight. So we want this gradient to be minimum for the weights that we are calculating. And one more thing, what we have done in last course is that our assumption that y cap is equal to bias plus w1x1 plus w2 is a linear model, and we cannot expect the data to be linear always. So what we have done is we have to introduce non-linearity, to introduce non-linearity, we added activation function. So what the activation function will do, it will transform the input to particular output. So the first activation function that we have seen in perceptron is a step function. What it will do, if your input is less than 0, it will make your output as 0. If your if your output input is greater than 0, it will make it 1. That's it. That means whatever may be the input, your output has only two values, either 0 or 1. So if you plot a graph, uh, this will be, if your output is, suppose this is x, so this all values will be 0 asymptotically. Then once it crosses this one, it will be 1. So it is a discontinuous function. You cannot derive it because it is discontinuous. We cannot differentiate it. So secondly, we talked about sigmoid function, output function. What is sigmoid function? It is defined as 1 by 1 plus e to the power of minus x. If x is equal to 0, sigmoid will be equal to 1 by 1 plus 2, that is equal to 0.5. If x is positive and large, then e to the power of minus infinity, 1 will be negligible with e to the power of minus infinity. So 1 by e to the power of minus infinity tends to 1 by infinity, and sigmoid will be 0. Then if x is negative and large, sorry, if it is e to the power of minus infinity, then it will become 0 and sigmoid of x will be equal to 1. If it is negative large, then e to the power of minus into minus, it will be plus, and 1 becomes negligible. 1 by infinity is 0. So sigmoid function will always be between 0 and 1. And when we draw a graph of sigmoid function, so when x is equal to 0, it is 0.5 here, and it is something like this. This is sigmoid function. And one more thing, we can derive it, and derivation of sigmoid is can be proven as sigma into 1 minus sigmoid. So here you can see that 1 by 1 plus e to the power of minus x derivative is 1 by x derivative is 1 by 1 plus e to the power of minus x whole square, and e to the power of minus x derivative is minus x. And this you can simplify, and you can find out that you can write it as 1 by 1 plus e to the power of minus x into 1 minus 1 by e to the power of minus x. You can write that without any problem. This is the second activation function. And the third activation function that we discussed is rectified linear unit, ReLU, which is the most widely used activation function. What is the purpose of activation function? Purpose of activation function is to add non-linearity to the model. We want to add non-linearity to the model. So ReLU is, if your x is less than or equal to 0, it will output as, it will give the output. We can, rather than calling it y, because we are calling the label as y, f of x is equal to 0. Otherwise, else f of x is equal to x. That means simply all negative values it is making 0, and all positive values it is giving the same value. So it is something like this. All negative values, whatever may be the, if x is negative, it will make it 0. And if it is positive, and it will produce the same value. This is a ReLU. That means you are avoiding all negative values. So that's why it may be some disadvantage, because you are completely ignoring negative values. So people started some uh, tweaking with this function, and they called it leaky ReLU. That means if x is less than or equal to 0, we will not directly produce f of x as 0, but some factor, maybe some small factor into f of x. They will multiply it with a small factor. So instead of 0, it will make some value, and once it crosses the 0, it will give. So this is leaky ReLU. Then people uh, played with truncated linear unit. And fourthly, we can also use tan h, tangent, tan hyperbolic x as a linear unit, which will accommodate values, negative values also. So these are the major aspects of machine learning, and we want to shift to deep learning because certain problems are not solvable by machine learning. Let me uh, walk you through those things in the next class.